Welcome to This Explainer. Look, if you've been tinkering around with local AI agents and you're finally ready to take them out of your terminal and unleash them into the real world, you are in exactly the right place. Today, we're diving into the ultimate guide to transitioning from those basic, locally run AI scripts to fully deploying autonomous CrewAI agents up in the cloud. We're literally taking your code from a fragile local prototype and turning it into a live, scalable backend brain that is ready to power absolutely any interface. Here's our roadmap for today. We'll be covering conversational versus agentic AI, prototyping versus production, and the incredible power of MCP. After that, we'll prepare the code base, run through the cloud deployment pipeline, and finally test the deployed API. Don't worry, we're going to break all this complex jargon down into super actionable steps. Okay, let's dive right into this. Section 1, Conversational versus Agentic AI. To really understand why cloud deployment of these crews is such a game changer, we first have to recognize the massive shift happening in how we actually interact with AI. For the past few years, we've basically been living in the era of conversational AI. You know the drill. You ask a chatbot a question, and it gives you some text back. It might recommend a great movie based on your tastes. But agentic AI? Oh, that takes proactive action. An agentic system doesn't just suggest the movie. It actively navigates the web, buys the ticket, orders your favorite snacks for delivery, and securely adds the event to your calendar. And it does the whole shebang without you lifting a finger after that initial request. You're no longer just chatting with a bot. You're handing an autonomous agent a job to execute. Moving right along to Section 2, Prototyping versus Production. Because let's be real, if these agents only ever exist on your local laptop, they aren't actually very useful, right? When you're just starting out, you're likely using a lightweight tech stack for local prototyping. This is great for getting quick visual feedback. Maybe you need to show a client a fast proof of concept. As our source material points out, a brilliant modern prototyping stack includes UV for blistering fast project management, Chainlit for spinning up conversational UIs with literally just a few lines of code, Little LM to act as this awesome universal connector to different language models, and Google Gemini Flash, which is just fantastic for incredibly cost-effective, high-speed testing. But here's the catch. A local script is fragile. When you transition from that lightweight prototype into a live production environment, the entire paradigm shifts. Production architecture has to be built for fault tolerance. I mean, what happens when an API suddenly fails? It also has to be built for scalability, meaning it's capable of handling millions of concurrent users without the whole application crashing and burning. You simply can't rely on your local machine forever. And as we scale up to production, we inevitably hit a massive bottleneck: tool integration. How do we give these agents secure, reliable access to external databases? Well, that brings us to Section 3, the power of MCP. The Model Context Protocol, or MCP, fundamentally changes the game for developers. Introduced by Anthropic in late 2024, MCP is basically a standardized way to connect AI models to the outside world. What's really interesting about this is how much of a headache it solves. Previously, connecting a database meant manually coding these massive RAG, or Retrieval Augmented Generation systems. You had to painstakingly manage 5 different types of memory manually: short-term, long-term, contextual, entity, and user-based. MCP just eliminates that nightmare entirely. It acts as this beautiful, universal plug-and-play standard. And the community adoption? It has been absolutely staggering. There are already over 1,100 MCP servers out there built by the community. Need your agent to read a GitHub repo? Boom, there's an MCP for that. Need it to query a complex SQL database or send a quick update to Slack? You just connect the existing MCP server. You completely skip having to write custom APIs from scratch just to give your agents their tools. All right, with the theory out of the way, let's pivot to the practical execution. Section 4, Preparing the Codebase. Let's say your CrewAI is working flawlessly on your machine. What exact code tweaks do you need to make before pushing it to the cloud? Well, there are 3 highly specific, non-negotiable steps here. First, take a close look at your final execution flow. Locally, you probably used a print statement just to see the output in your console. You absolutely must change this to a return statement. A cloud API needs to actually return data over HTTP. It can't just print to a headless server. Second, map the command. Open up your pyproject.toml file and map the execution script so that when the cloud runs the run_crew command, it points directly to your main kickoff function. Third, once those tweaks are dialed in, go ahead and push your entire code base to a GitHub repository. Honestly, if you take away literally anything from this coding section, just remember the super simplified rule of thumb. Ensure the flow actually returns a value, and explicitly tell the server how to run the crew. If you nail those two things, your code is structurally completely ready for the cloud. Which brings us to the most exciting part, Section 5, Cloud Deployment Pipeline. So we have our prepared code just sitting there in GitHub. How do we actually get this onto a live server so the world can use it? Well, the crucial point here is how seamlessly CrewAI has integrated their cloud platform directly with standard version control. You don't need to be some hardcore DevOps engineer manually configuring Docker containers and AWS instances anymore.
The pipeline is just incredibly straightforward. First, log into the CrewAI Cloud dashboard. Second, authenticate your GitHub account and select that repository we just pushed to. Third, and please, this is vital, input your environment variables, things like your Gemini_API key or OpenAI keys. Never, ever hard code these in your public GitHub. And finally, just click deploy. Behind the scenes, a CI/CD pipeline containerizes your code for you. Oh, and it's definitely worth noting that the free tier currently allows up to 50 requests, which is totally perfect for testing out your deployment.
Actually, quick aside here, for those who might not want to write all that Python code from scratch, there is something called CrewAI Studio. This lets you generate a whole visual graph of agents and tasks, literally just by typing a prompt. You could say, I need a hotel receptionist crew, and it builds the agents, assigns the tasks, hands them tools like SQL database access, and gives you a one-click deployment button. It's a fantastic alternative that just abstracts away the manual code-based prep entirely. Let's assume our GitHub deployment just finished processing. We are officially live. But, a back-end deployment is completely invisible until we actually interact with it. So let's jump to Section 6, Testing the Deployed API. When CrewAI deploys your project, it automatically wraps your code in a super robust API and generates 4 very specific endpoints. You've got the kickoff post route, which is what actually starts your agentic crew. Now, because execution takes time, it hands you back an execution ID. You can then use the status get route, pass in that ID, and check if the crew is still processing or if it's finished. The input route is great because it tells front-end developers exactly what variables the crew needs to even start. And health? That simply confirms your server container is alive and kicking without crashing. This brilliantly illustrates the power of fast API running under the hood. It means if you take your live deployment URL and simply append /docs to the end of it, you instantly get this fully interactive, auto-generated Swagger UI right there in your browser. You don't even need third-party API testing tools like Postman. You just plug in your secret bearer token, which you grab from the dashboard, to authorize yourself, and boom, you can trigger your autonomous crew directly from the web interface. And just like that, you've done it. You've crossed the chasm. You are no longer just running little local scripts. You have deployed a secure, token-protected, cloud-hosted API. Whether you want to connect this thing to a sleek Next.js front end, a mobile app, or even a Slack integration, you now possess the power to build the back-end brains for absolutely any UI. The architecture is ready, the tools are standardized. So the only question left for you is, what autonomous agent are you going to deploy first?